What is the problem you guys are trying to solve?
Yeah, we're actually trying to solve mainly two problems, and they are the most important unsolved problems in modern AI. The first one, which we're famous for, is long context understanding and memory in AI systems. So, even with today large models like Claude, ChatGPT that you use daily, they still stuck on a specific context window that actually they can't work with more than a specific number of tokens. So this actually is an insane bottleneck in today's AI, and it remains unsolved to this day. So we're at Quasar aiming to solve this. And the second problem we're trying to solve, which is decentralized training, but not just any decentralized training, it's for mixture of experts or MoEs models. So MoEs is a very powerful architecture. Every AI model, every frontier AI model like big AI, Claude, GBT, etc. They're all under the hood. They're all a mixture of experts models. It makes training cheaper, inference, etc. But training MoE model in a decentralized environment is an absolute nightmare. You suffer from a lot of challenges, routing, stability, speed, and this still remains unsolved. And these two problems we were trying to solve is actually what make us 724 Quasar, and we have the right path, or we believe we have the right path to solve both.
And you guys started off with purely, we're going to attack long context with the subnet. Why is this problem a problem? Like, why is this hard to solve?
Yeah, okay. So it's actually comes to the root of the models itself. The architecture of these models are built on the Transformers architecture. And what made the Transformers architecture really any special is the attention mechanism. And the attention mechanism is pretty basic. The model is looking at all the tokens at the same time. And this was good for a short context, but now people rely daily on AI. It's not possible to just keep going like this. I like to always say, imagine is now we have AGI, the smartest AI, and we ask it to solve cancer, but it can't. Sorry, you hit the limit for today. You need to wait. So this is actually a pretty stupid idea because the architecture of AI models itself are limited. So that's what we are trying to do is create this new architecture. Where we already found the best architecture that could and solves long context today.
When you guys approached Joseph Jacks, what did you have at the time and how'd you find him? How is he the person you're like, we should reach out to him?
Yeah, because I actually know Joseph Jacks from Liquid AI. I was a big fan of Liquid AI and their CEO and their work. I worked on Liquid Foundation models, not with them, like on just the topic and I was interested in that he saw the vision on them with Liquid neural networks, which is trying to also find the way for I think beyond transformers. So I thought, yeah, he believed in Liquid AI, then he will see the vision in Quasar as well. We're trying to solve the almost the same problem, but in a different way. So I reached out to him, and all what we had right now back then it was the Quasar architecture. We didn't have the model, we didn't have anything. So he said, you guys are seem smart, but I think you should start in Bittensor first, and that what we exactly did.
Okay, let me look for the next question here before we just get
Sure.
into the subnet. Um, yeah, I guess how are we going to attack this as a subnet? What's the plan here? How'd you guys do it with the first iteration with long context?
Yeah, okay. So first, before for our new system, we started as this. We asked miners to build Quasar kernelized attention. So what Quasar is, it simply process tokens token by token. So this is actually kind of slow. And to solve this issue, we had to create coda kernels. And coda kernels is, with simple terms, is you compile the GPUs to work with your architecture. Okay, so that's what we asked miners to do to make Quasar that's attention that already solve long context simply way faster. But we saw that but this actually remains a bottleneck for us. How we are going to train Quasar, how is going to be state of the art? Because yeah, having a model that can process long context is cool and everything, but if it can't do anything, it's kind of useless. So we decide to utilize the power of Bittensor and the experience with Bittensor miners, since they're able to train an entire 72 billion model on their own. So that's quite cool. Then we transform to this goal that we need to be decentralized, and we just let the miners do the heavy work for us and train Quasar with us. So that's what we kind of do now, that we distill knowledge from larger models like Qwen and other models into Quasar. So Quasar is not just a cool long context model, it's actually state of the art long context model.
You guys are currently doing model distillation with the subnet?
Yes, indeed. So I know we're kind of solving everything these days, but how it goes that we handle the teacher part, where we have a model like Qwen. It generate the outputs based on our data, and then miners with our MoE decentralized setup, with our architecture, with our Quasar architecture, they distill this knowledge from the larger models into Quasar. So Quasar is actually becoming state of the art right now.
How do you compare yourself then with something like the distill subnet run by Arbos?
Actually, our pods just focus on distilling into just dense models, and that's it. They just want the models to be better. But what we actually introduce is the Quasar architecture. Having long context. So you're training a Quasar model, which is already trained on millions of tokens, process millions of tokens, and already have a large context window. So it's not just any model; it's the Quasar models. And also with our MoE setup that is already faster than the normal decentralized, we made some breakthrough there. So we're not just another RPO subnet. We are Quasar subnet that do distilling for state of the art, and do MOE decentralized training, and do long context training.
The long context training, I think we covered. The
Yep.
decentralized training of mixtures of experts. That
Mhm.
subnet is not live yet. That's something you will do in the future.
Actually, we're working on as we speak.
Okay. And what is the design for that for miners and validators?
Yeah, it's still in planning, but what we have and what we pulled off right now with our testing, that each miner will have kind of their own expert. We build this MOE architecture that it's not all to one, all to all communication. So what we can do is the current MOE design is simply you're talking to the same experts all at once. And this is designed and decentralized is bad because you may have a miner in different places, so you can't do this right away. So what we did is we made this MOE design that can communicate one by one and also be fast at the same time. So this is the current breakthrough that we made in this MOE design. So right now, each one of them will have their own mixture of experts, their own wets, and they all process the same data, which is the distillation data from Qwen, and they train their own expert or their own wets from Quasar, and then validators, just metric class, metric MOE loss, and how close is that to the teacher outputs?
What are the data sets you guys use to train the models?
It's actually fully open, and there's a kind of note on the future. I can't say right now, but we have a partnership with a pig player that actually they recently raised money, and we will announce soon. But they will handle the data part for us. So we actually not just distilling from very good models. We have data that was only for state of the art models, and now it's fully for Quasar.
Okay. And in terms of the training for the mixtures of expert, you're saying each miner will train one expert. So expert parallelism across miners? Is that the way to understand that?
Yeah, exactly.
Okay. And what has you excited about this subnet direction here? How big do you think you can go? Or is that the wrong metric to look at?
Big, yeah, is one of the metrics that we can focus on, but better is what I'm looking at. Because now in decentralized setups, you have these very successful runs, but there's no use of these models. Right? You don't use Subnet 3 model. You don't use the other decentralized training run models. Why? Because they don't focus on quality. But with this setup, you're not just solving the decentralized problem, you're solving the quality metric. So this is a thing that I don't think has been ever introduced. You never used a decentralized model before. And this is what we looking at, creating state of the art, and also something that you can use daily and a real model.
And does the real model part just mean benchmark maxing?
Of course not. Like benchmark means nothing if you don't use it in your daily workflow. But what I mean is, now that we have data that it was only for state of the art labs, and we're distilling from larger models, that is more important. And Quasar itself is a long context, so we added this new unique thing into Quasar that is now it can work almost like with no limits. It can process 10 million tokens with no issues, with no speed drops, with no issues in quality. So this is the uniqueness of Quasar. So what we only need is just to make it better at understanding everything so people can actually use it.
And in terms of the distillation aspect of it, could you guys add like GPT 5.4 and like Anthropic's Opus 4.7? Are there plans for that? Or is it purely like open source models?
Sadly, we can't do this. Not because it's impossible, but because first it's gonna be expensive to distill from these models, and also it's actually against their policy to distill from their models' outputs. And to be honest, right now, like models like Qwen, GLM, they are actual competitive to these models. They're not that far. And with long context, we found a new scaling law that actually models get smarter when they deal with context way better. So this is something that we believe will solve the edge between open source and closed source. No matter how much open source get better, there's this gap that remains unsolved. So, and that's what we actually did in Quasar, trying to solve this gap that we're not just going to be, smarter as Qwen. We're going to be smarter as Claude and ChatGPT. And I know this are big words, but there's a way for this.
Say you guys complete this mission, you make this model.
Mhm.
How does the value capture aspect of this work? Will the model just be then hosted on shoots and then people use it that way?
Yeah, and actually, we have a partnership with Shoots to host Quasar later. But yeah, that's the main point of this. In terms of utilizing these models, it will be used through APIs. You know how you use Claude every day through APIs, and we even have our own product, which is Quasar Copilot, that mainly utilize the long context of Quasar for daily workflows.
So the hosting of the model and the inference you think will be on something like a shoots. You don't
Yeah, of
plan on doing
course.
that yourself? Okay.
We have our own API that is coming, but for the current time, we just focus on working with the subnets. So we'll leave this part for shoots.
What is the hardest part of all of this for you?
It's actually all of this are very hard, but the hardest problem is to actually make this an incentive mechanism. So yeah, like subnets are pretty cool, but making a good subnet is something pretty difficult. And but we actually have a lot of help from Const, from Targon team. They all, you know, what I like about potential that everyone here just want to help you because if you succeed, they succeed. So the building the incentive mechanism is the hardest part, but it's not impossible. We actually have a path for this. We have a work on this already. So that's the hardest part, but we gotta do it.